All right. What's up, party people? STEM fans, STEM coders, codestronauts. I don't know what you guys want to be called, but you're all my friends no matter what. Let's get to it. I don't know how far we're gonna get today. I haven't been paying very close attention to my timer lately, but that's fine, because I love spending time with you guys. So to recap what we've been doing, I should probably open VS Code. We recently, TwilioQuest, close this other stuff. Close that. TwilioQuest, here we go. I don't know which one we left off at. Freighter inventory or something maybe? No, definitely not it. Laser, North Bridge Control. Anywho. Sorry. Excuse me. Oh, there's the for each. Oh no, we left off with reduce, right? Where's reduce? There it was. Freight mass, this is the last one. So last episode, I don't know if you guys remember, it took forever for me to, whoops, I don't know what I just did. I'm gonna get out of this. Get out of here. What is going on? Keep on doing the magnifying glass, sorry, instead of, just zooming in like this. There we go. Sorry. So we did reduce, and we figured out what step 4 was with the reduce method, and then we were able to do 5, which is finding arrays and indexes of arrays and arrays. Indexes of an array in another array, so nested arrays. So we've gone through all of these chambers here. We have all of the coordinates. I believe it keeps track of all of them for us, so hopefully we don't have to remember all of them. We did have one kind of extra thing here, I think, maybe? I thought, but it's not letting us select it. Maybe we already did that. I don't know. So now it's time, moment of truth. We've been working on this for what, 3 episodes? To unlock this laser gate and talk to this engineer in here. So let's do it. The electrical engineer is trapped behind this security barrier. Solve the puzzle of the infinite loop freighter to free her. Let's do this. Enter the password required to unlock this barrier. See the object tab for more help. Objective tab. Beyond the barrier, you can see the TwilioQuest research team's electrical engineer. She has one of the activation codes you need to restart the ductipium experiment. Okay, that's what we need. However, she is still trapped behind a barrier that is different from the others aboard the infinite loop. This barrier requires a special 6-letter master password. The clues you need to decipher the password can be found by exploring the rest of the ship and hacking into the security nodes present in the ship's 6 secure cargo holds. Once you have hacked all 6 security nodes, you may return here and attempt to guess the password. So we have all 6, I believe. The infinite loop's master password is 6 characters long. Each character in the password can be found in the following 2-dimensional array. Okay, so we just learned about 2-dimensional arrays last episode. That was the last thing we did. I said nested array, so that's probably not the right verbiage. But here we go. So we have all of our coordinates. That's what you want to call them. What do they call them in here? Indexes. So let's do it. So the first character is 1, 3. So we're gonna do, in this two-dimensional array, this is the 0th index, so it goes 0, 1, 2, 3, 4, 5. So we're gonna go 0, 1, so we're in this array, and then we're gonna do the third value in there, so we're gonna go same thing, 0, 1, 2, 3. So the first character is F. Second, same thing, 0, 1, 2, 3, 1, 2, 3, 4, P. I wonder if this has to be capitalized. I'm assuming so. It's case sensitive. Alright. Third one, 0, 1, 2, 5, 0, 1, 2, 3, 4, 5. FPN. Okay, fourth one, 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay, exclamation point. Fifth character, 0 and 4, 0, 1, 2, 3, 4. So it's a T. And then lastly, sixth character, 0 and then 2, 0, 1, 2. E. I think this is right. Failed? What? How is that possible? F. Did I do something wrong? 1, 0, 1, 2, 3. F. 2, 0, 1, 2, 3. 0, 1, 2, 3, 4. Oh. This one is an exclamation point. Finite? There we go. Success. The laser barrier fades away, and you are able to proceed onward to speak with the electrical engineer. Nice. Well, hello there, engineer. How did you get here? I mean, I'm glad you made it, but I thought it would be days before your rescue team figured out the infinite loop security system. Well, it was months, but thanks for being so kind. You need my code to reset the laser in the experiment room? By all means. Here's the hardware token you'll need to activate beam 3. You must be something else, even for an operator. Thanks, it was a bit of a runaround, but I'm glad I could help. Ha, run around. I get it. Bonus points for the loop pun. Like it. On top of it all, I'll head out to the experiment room after I finish up in here. You're still gonna work after you've been trapped? Workaholic in there. Hey, don't shame her. Alright, so we got all this stuff unlocked. Do we do this thing? Oh, there's nothing in here. Now we, whoop, So you need to go all the way back. Here. Do we need to go up here? Let's not go up here. Let's think we can do any of these? Use the botanist activation code and your knowledge of Boolean logic to enable the stasis beam. Oh, we should have done this right after we finish this. Using the botanist activation code, you access the controls to the stasis beam. After running a quick diagnostic routine, you see that the laser is missing a key piece of functionality, the script that sorts strings in alphabetical order. You'll need to rewrite the sorting script in order to restart the laser, okay? In your code folder, create a script called sortorder.js. sort, sort order JS. This script will take two command line arguments, a pair of strings that should be compared to see which one comes first alphabetically. Take two command line arguments, a pair of strings that should be compared to see which one comes first alphabetically. Letter casing is not important. To test your script, you could execute it like this. Okay. Your script should determine if the first string is before, after, or in the same position to the second string alphabetically. For each case, you should print out a number with console log as described below. When the first argument is earlier than the alphabet, in the alphabet, then the second, your script should print -1. When the first argument is in the same as the second, the script should print 0. The first argument is later in the alphabet than the second, your function should print 1. When your script implements this comparison functionality, click the hack button to restart the laser. Okay. Sort order JS. So let's create TwilioQuest, new file, call it sort order JS. And I believe like I said, we should have done this right after we were done with the botanist stuff, because it probably was fresh in our brains. But let's look at the help and see what they tell us. After learning about conditional logic in the South Wing, you're ready to take this on this challenge. Create a file named sorter. Okay. Use the following code as a starting point. Your code will need to print out one of three numbers based on whether the yep. Okay. Alright, so this is the code they gave us. And then we're going to do if statements. So if we do pseudocode here, we're going to say if first value is, let's say before second value, then we are going to, what's the condition? We're going to console log -1, right? Console log -1. Else if first value and second value are the same. Whoops. Second value. Then we're console logging 0. Here, there we go. And then the final else is if the first value is after the second value, then we're gonna console log 1. Now, this is pseudocode, so how do we actually compare these two? Let's see what the old TwilioQuest says. Your code will need to compare strings with alphabetically as demonstrated here. You also may need to convert the strings to the same case before comparison using two lowercase. Nice. What does this go to? Comparisons. String comparison. Oh, you can just do. You see whether a string is greater than another. JavaScript uses the so-called dictionary or lexicographical order. In other words, strings are compared letter by letter. For example, alert Z is greater than A. Okay. Alert glow is greater than glee. Okay. Alert B is greater than B. Okay. So in ours, if since cats comes before dogs alphabetically, so if it comes before, that would be less than, right? First value is less than, second value equal, and dogs would be after, so greater. So I'm assuming if you gave number values to the alphabet, A would be 1, Z would be 26. So if A is less than Z, that makes sense. Should we try it out? We haven't solved for capital, like uppercase and lowercase letters. So we might have to do that next. But let's see. Let's just start with this first. So if we go node, sort order JS, and then we do cat dog. Oh, we got an error. What's the error? Oh, I'm not in the right thing. Whoops. CD TwilioQuest. There we go. Now let's see if it works. Still doesn't work. What did I do wrong? Unexpected token. Matt? Why is it unexpected? What am I missing here? I have to do else if. Oh. Oh yeah, because I have a condition here. Whoops. So I could technically just do else, but I'm still comparing things. I do else if. Alright, let's save this. Try this again. -1, which is what we want. And if we switch these and do dog, do zebra and dog, it should be +1, right? Yep. And if we do dog dog, 0. What if we do capital dog? Oh, it gives us -1, which is not what we want. So how do we do? What do we do? 2 lowercase? Can we add that to progress RV? Possibly? Let's look at it real quick. .2 lowercase. So we have a string and then we do .2 lowercase. Alright, let's try it. So we'll have a string here and we'll do .2 whoops, caps lock's on, to lowercase, to lowercase. Think that'll work? Maybe. Nope. Does not work. Does not work. To lowercase is not a function. Let's make sure I did everything right. Oh, capital C. Capital C. Let's see if this is wrong. I'm still not sure if you can just add it to the argument. Maybe you can. There we go. Yeah, you can. Cool. Looks like she works. So to go over this real quick one more time. We have two values, first value and second value. These are the arguments in the command that you run. So second argument and the third argument. So this is 0, 1, second argument, third argument. And we take that and we compare these. We can delete this line. Say if the first value is less than the second value in the alphabet, console log -1. Whoops, console log -1. If they're equal, give them a 0. And if the first value is greater than the second value, give it a 1. That's it. And JavaScript uses string comparison. So dictionary order or lexicographical order. So the way I look at it is each letter has a number value assigned to it. So A would be 1 in the alphabet and Z would be 26. So if you took 26, is 26 greater than 1? Yes. That's kind of how I look at it. Probably a better way to look at it, probably a better way to explain it, but it's kind of what I see, how I see it. Let's do hack. Success, baby. Your comparison script appears to be working. Status beam 2 flashes to life. Nice. Should we do 1? I should do 1, huh? Previous attempt to stabilize the ductopium ended in disaster. Now you must get all the 4 stable beams back online to reverse the experiment. You reverse the failed ductopium experiment to bring all the 4 status beams. Lead scientist told you that her colleagues have activation codes ready to restart the 3 laser beams. Search for the rest of the lab for these codes. Once the 3 beams are back online, turn here to enable the final beam. Okay, so I can't go to this one. That's why I haven't done it yet. So I have the first one, second one. Use the electrical engineer's activation code and your knowledge of loops and iterations to enable the status beam. Okay, so you input the electrical engineer's passcode. The display comes to life and you start to troubleshoot the systems connected to beam 3. It looks like the beam was knocked offline due to an error in how it calculates the power to send through the laser beam. This logic is governed by a JavaScript function that you'll need to fix. You'll have to draw on everything you've learned about arrays to overcome this challenge. Whew. Okay. Create a file called laserpower. Firepower. In your code folder, inside this file, create a JavaScript function called calculatePower. This function should take one argument, an array of numbers. This array contains the aggregate power settings for the laser, but the input numbers are off by a little bit. Your calculatePower function should first adjust all the values in the input array by multiplying them by 2. Afterward, you must add all those numbers together and then return the result from your function. Once your code is ready, click the hack button. That's a lot. Alright. So let's just get moving here. So let's create another file. Call it laserpower. So I'm assuming we're gonna have to use a map function, a reduce. I think just map and reduce. We'll see. What does the help say? To complete this objective, you have to combine several techniques you've learned. Create file, yep. In this file you must create a function called calculate power. Yes. Oh, it already has that here. Here's some code you can use as a starting point. It already has the function defined, but doesn't yet work as described in the objective. Yeah, I think it's just map and reduce. In the east wing, we did do 4 each. But, excuse me, I don't think we'll need it here. So let's minimize that, bring this down for now. This is what we got right now. Calculate power. So we need it, to multiply every array index value in the array by 2, and then also add all of them up. So let's see here. So we can take power settings dot map, and then should we do an arrow function here? Let's do that. If it gets too complicated, we can go back to the function, old function. Sometimes it just helps me look at it a little better. And then we're gonna, for every value, let's do I, and then just gonna do I. Are we doubling it or squaring it? Anyone know? Objective. Multiplying them. Okay. So times 2. Okay. Is there a times equals? Can I do that? Like, you know, we can do plus equals. Can I do multiply equals? Should we search it? So you can do plus equals JavaScript. What is that called? Addition assignment. But we don't want that. We want, is there like a menu? I thought there'd be like a sidebar. Yeah, there we go. There should be one, I would think. Multiplication assignment. Yeah, there is. Okay. Okay. So we're gonna map. And then just to test it, let's console log I. And then save. So we multiplied them, I think, correctly. So it would be 2, 6, 16, which is 16 plus 6 is 22 plus 2 is 24. Okay, so we have those right. And then we need to reduce. Actually, I'm going to leave that there for now. And then let's take let's see, what's the best way to do this? Whoops, wrong thing. Help. Give me the reduce function. Sorry. I think the best way to do it is to put it on the outside. So so you put the reduce around this map. So we have I, and then you would do what you do power settings dot reduce oops, and then pull this into there. Format that for me, please. Thank you. We need to. This formatting's weird. Anyways, so for reduce, we had a hell of a time with this last time. We have the accumulator, and then sorry, I'm drawing a blank. Okay, and then we are going to add that up. So let's do some would be but we don't have the array value. Okay. Do this maybe not as efficiently. We're gonna map first. Oops. We're gonna map first. And then we're gonna I dot push to items. I think I was gonna push to the power settings array. So we're gonna power settings array, sorry. We're gonna push I. And then let's, after that's done, see what it is. A console.log power settings. See what it looks like when it's all said and done. Oh, we don't want that. We do not want that. Let's make a new one. We're gonna make a new array called let. We're gonna do power times 2. That's a terrible name, but that's okay. And it's just gonna be an empty array. So we're gonna push our new values to power times 2. Let's see what that gives us. Okay, so now we have our new array. So let's after that we're going to reduce over power times 2. So we're going to do power times 2 dot reduce, and then we're going to do this is probably definitely not the best way to do it, but it's okay. Some current, we can spell current right, and we're just gonna do, oops, the current value plus the sum. So we're gonna do, I guess we don't really need curly braces here. We can just do sum plus current, and then we'll make the initial value 0. And we'll do, there we go. We're back. Looks like we got disconnected. I think we're good to go now. Console log total power. See what happens. 24. Required laser power is 24. We got it. Should be 24. So let's clean this